What do you think would be Einstein's favorite experiment? I mean, Einstein was a theoretical physicist, so he never did experiments. Mathematics was the main tool for his science. He used to write field equations, wave equations. But there is still one experiment which we potentially can call Einstein's favorite experiment because it is that very experiment which helped Einstein to formulate his special theory of relativity, due to which he gained so much popularity in the beginning of the 20th century. And in fact, the setup which this experiment used is being currently used to detect the presence of gravitational waves, which are another of Einstein's prediction. And there is a huge coincidence between this experiment and Albert Einstein, and that is that this experiment was also performed by another Albert Michelson, along with Edward Morley, and therefore it got its name known as the Michelson-Morley experiment. And this experiment is regarded as one of the greatest field experiment in the history of science. It all started in 1865 when James Clerk Maxwell, another physicist, used these set of equations to prove that light was an electromagnetic wave. Now, if light was an electromagnetic wave, many physicists thought that it must need a medium through which it can travel, through which that electromagnetic wave could express its speed. Because any type of wave, either sound wave or a water wave, needs a medium to travel. For example, a sound wave travels through air. So air is the medium for the sound waves to travel. So physicists hypothetically called this medium through which light traveled as the ether medium. And they thought that since light travels through vacuum, so this ether medium permeated all throughout the vacuum of space, and different objects were moving in relative motion with respect to the ether medium. So the Michelson-Morley experiment used a principle in order to experimentally prove the existence of the luminiferous ether medium. And the principle which it used was that if the ether medium permeated all throughout the vacuum of space, and the Earth is traveling through space around the Sun, then the Earth must be in relative motion with respect to the ether medium. Because the Earth is constantly changing directions with respect to the ether medium, therefore the magnitude of this ether is constantly changing and is variable with respect to different sides and different angles. Now, light waves traveling in different directions will have the same speed with respect to the ether medium. However, the speed of light in different directions will change and will be different with respect to the Earth or with respect to an inertial reference frame. This is because Earth is in relative motion with respect to the ether, and therefore it's constantly changing magnitude with different directions and different coordinates. And because of that, the speed of light in different directions or in perpendicular directions will be different with respect to Earth or any other inertial observer. So the main idea behind the Michelson-Morley experiment is to actually calculate the difference in the speed of light in different directions or in perpendicular directions with respect to the Earth. And because of that difference, they'll be able to calculate the speed or the velocity of Earth with respect to the ether medium, thus proving the existence of the ether medium. Now, physicists also predicted that light waves traveling parallel to the ether medium will travel much more slowly because of less velocity as compared to the light waves traveling perpendicular to the ether medium. The Michelson-Morley experiment used an interferometer as a setup. So it had a light source which produced monochromatic and coherent light beams, and in the center it had a partially silvered piece of glass. This partially silvered piece of glass allowed 50% of the light waves to pass through it and 50% of the light waves to be reflected. These light waves, which were reflected and which passed through, were reflected again by the mirror 1 and the mirror 2, which were placed at perpendicular directions. After being reflected from the mirror 1 and mirror 2, these light waves met together on a screen and produced an interference pattern. This happened because the light waves coming from perpendicular directions had different path lengths. And because of these different path lengths, the light waves interfered with each other since the crest and the troughs of these light waves were out of phase, due to which it underwent some constructive and destructive interference to produce a net interference pattern. Now, Michelson and Morley thought that if the Earth was in relative motion with respect to the ether, then the interferometer must also be in relative motion with respect to the ether. Therefore, the speeds of light in different directions in the interferometer must be different with respect to the frame of reference of the Earth. So, if we tilt the entire experimental setup 90 degrees or perpendicularly, then the speed of light in different directions in the interferometer with respect to the Earth will also change. And because of this change in the speed of light, the light waves will interfere with each other to a different extent, which would change the interference pattern and produce the fringes to actually move across. So we should see the fringes moving across, the interference pattern to be changing, and then we would prove that there is an ether medium. However, when they actually did the experiment, one of the greatest field experiments of all times, they did not see the interference pattern changing. They did not see the fringes moving across the screen. It seemed as if there was no ether and the earth was stationary through this ether medium. So, this experiment failed to prove the existence of the luminiferous ether. However, the results of this experiment became useful for another physicist in the future, the synonymous genius, Albert Einstein, because the experimental result helped him to develop his second postulate. That was that the speed of light remained constant and remained the same for every inertial reference frame, regardless of its velocity. And using his second postulate, he was able to formulate his special theory of relativity. He was able to describe relativistic motion and explain mind-blowing phenomena such as time dilation and length contraction. And the interferometer, which they used in their experiment, is being currently used to detect gravitational waves out of black hole mergers or neutron star mergers. And this is an expanding area of scientific research in the modern world. Now, Albert Einstein was so fascinated by this experiment that he even wrote that if the Michelson Morley experiment had not brought us into serious embarrassment, no one would have known the theory of special relativity in its halfway redemption. So, it doesn't matter if you have failed to prove something or if your experiment has failed, because that thing might lead to huge success in the future.